This lesson we are going to discuss lines and angles. Our objectives are pretty straightforward. Identify parallel, perpendicular, and skew. We want to identify angles that get formed by two lines and a transversal. So what this tells you, notice how it says identify vocab, 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 vocab. This is entirely 100% a vocabulary lesson. If you know the vocabulary, this is a look at the picture and tell me which one it is. That's all. If you don't know the vocabulary and you don't know the words, you will be screwed. I also want to point out this particular lesson is massively important because the next 3 lessons are going to build on this vocabulary. This one section and what the vocab is literally forms the basis for 2/3 of our unit. So we must get this down, and we need to get it down well. Here is the full list of vocabulary that we are going to go over. There are, of course, some things that we already expect you know. For instance, we expect you know what parallel and perpendicular would mean. Skew lines, maybe not so much. With your earlier classes, you were probably exposed to corresponding and alternate interior angles, but maybe you don't remember them. Now, ultimately, it's not as important. If you want to pause the video and just start writing these things down, you can. But having these things written in your notes are less important than actually understanding them. And of course, we do have our textbook resources. We have our online resources. You can grab them anywhere. You could go through and create some flashcards to help you study. The most important thing is simply that you know what they are and that you can recognize them. Parallel lines. They're coplanar, so they're on the same flat surface, and they will never intersect. So, for instance, if we extended our lines, these would be parallel. The symbol we use for parallel lines are these little arrows here. Remember how we had tick marks and tick arcs that said these segments are congruent or these angles are congruent? That little yellow arrow is what we use to say these lines are parallel. And I'm curious, can you identify other parallel lines? How about right here? With a second set of parallels, you'll notice that we use a pair of double arrows. It follows the same convention as our tick marks. How we'd use 1 tick mark or 2 tick marks or 3. Well, we can use 1 arrow or 2 arrows or 3 to show that we've got various sets of parallels. Continuing more, perpendicular lines intersect at a 90-degree angle. So it's tougher to see when we've got them drawn. And if we think of that, it clearly looks like it's an obtuse angle, but whenever we have 3D drawings, you need to remember that 3D drawings change the perspective, so things don't always look the way they would. If we were to rotate this box so that it's facing toward us, we would be able to see that this would be a 90-degree angle, and I'm sure you remember that 90-degree angles use that little box to say it's 90 degrees, so we have perpendicular. Likewise, we would have, and I'll do this one in yellow, right over here, because we've got another box, we have another set of perpendicular lines. And you'll notice I drew these as perpendicular segments. Remember that perpendicular lines do not end. They should have double-sided arrows on all of them. Unfortunately, it's a convention that a lot of times people will talk about parallel lines or perpendicular lines, but they don't draw the arrows. It's a part where so many people are sloppy with it that, frankly, we understand what you're talking about, so we don't really care that much. But we should. We should have the lines on it to be more precise. Skew lines are a little bit trickier. Skew lines don't cross. So in that aspect, a lot of times people think of them as parallel. The big difference with skew lines, they're not coplanar. Skew lines will not intersect, and they're not coplanar, so where we'd encounter things like that, we could have this line. Think of this as the line on the ceiling. Running along the wall, we've got the line on the ceiling. And this would be skew with, say, this one, WH. And I know when we draw those, it looks like they're going to cross. If we extended them further, we'd say, oh, look, check it out, they're crossing. But remember, these are not coplanar. These are different heights. The yellow one on top here, this is like the ceiling that we've got up here. And then the bottom one would be down here on the floor, going in a different direction. That's what skew lines have. Skew lines are going to be at different heights and going in different directions. You can see these a lot of times when you just think about a box. Holding the box up here, you can see we've got the top of the box in one direction, go to the bottom of the box, go a different direction. Those are skew lines. Skew lines, I'll say it again, different heights, different directions. And lastly, we'd have kind of the obvious. Parallel means that they don't cross. So parallel planes don't cross. And we get really obvious ones like the top of the box would be parallel to the bottom of the box. The left-hand side is parallel to the right-hand side. The front is parallel to the back. Now, one component that I have not really discussed here, the notation. We could have line AB is parallel. Some books like to use a pair of vertical lines like this. You will find other sources that instead of using vertical lines, will use a slanted line instead. I don't care which one you use. They both get used, so pick which one you like better. I'll tell you personally, I like the slanted one better simply because it's like a backslash. Backslash is easier than the vertical one, like canal or something. Now, each one of these pieces that we mentioned for the lines, you see how we said parallel line, perpendicular line, skew lines? We can have parallel, perpendicular, and skew segments also. And we would have parallel segments if we were to extend them outward and turn them into lines. If we extended them to make lines and they're still parallel lines, then we would call them parallel segments. Or if we had perpendicular segments, where we got that 90, if we extend them into lines, are the lines perpendicular? That's really all it is. Same thing with skew segments, because of course we don't actually have boxes or rooms that go on forever like a line, so. So, with this picture, tell me a pair of parallel segments. Frankly, there are so many correct answers here that it's just crazy. First ones that I would see, I'm looking at here and I see that I've got these double arrows and double arrows here. Recognizing that the double arrows tell me that they're parallel, I'm saying this one and that one. So that's N to S is parallel with M, R. We're done. That's one answer. They didn't ask us for 5 pairs. They said 1 pair. What about a pair of skew segments? Skew are different height and different direction. So I'm going to pick this one up at the top. And you'll notice that if I pick this one at the bottom, I've got a problem. Because they're going in the same direction. If I pick this one, I'd still have a problem. And this one right here is sometimes a little bit trickier for students to see because a lot of times students will think that skew segments means they can't be on the same face. When I took this original one here, it's pretty obvious that this and this are on the same, like, left-hand side, the same card over there. And so students generally will say, okay, no problem there. But you need to be careful because it's not just there. These still have the same direction. And you could think of like slicing this little house of cards down through the middle. We could put a piece of paper that would still connect through these 2 purple ones. Those would not be skew. These are still parallel because they have the same direction. This one, though, doesn't have a problem. Wow, that's ugly. So for this, we could say NM is skew with LQ, and we're done. What about perpendicular segments? Well, we need a 90-degree angle. You can see that I've got a box drawn right there, so they're telling us that's a set of perpendiculars. So let's grab those 2, and that would give us NS is perpendicular with SR. Parallel planes. The key feature to remember about planes, of course, planes need 3 points to name them. So we could say plane, and just for the sake of ease, I'm going to grab the top is parallel with the bottom. And so taking 3 points from the top plane, N, L, M, order of the points doesn't matter at all, is parallel with plane, and 3 points from the bottom, PRQ. There we go. If you'd like to get into a little bit of extra practice, pause the video, try them out. We won't go over the answers here, though. Here's a bunch more vocabulary. And again, it's not so important that you have the specific stuff memorized word for word. It's more important that you can recognize them when we use them. Now, you'll notice what we've got drawn here. We've taken 2 lines, and it's pretty clear that these lines are not drawn as parallel lines. Everything that we are doing right now does not require parallel lines. If you've worked with these things before, there are some special facts about them when the lines are parallel. And so a lot of times people think of the standard parallel line picture, but I want to emphasize we do not have to have parallel lines to have corresponding angles. We do not have to have parallel lines to have alternate interior angles. We will approach them that say, when the lines are parallel, what special facts do we know about these things? We will go there, but don't think that you have to have parallels, because you don't. Based on these ones, our first term that we would have is a transversal. Transversing means crossing. So a transversal is a line that crosses. That's it. Well, based on these two yellows, where is a line that crosses the two yellows? Hey, I wanted that in blue. Give me my blue. There's our transversal. Usually we use the letter T to remind us that it's a transversal. We don't have to use T. There's nothing special about that letter. It's nice to use just to remind us. You'll notice then that when we cut the transversal, we got a lot of lines that create a lot of angles. These angles occur in special types of pairs, and that's what each of the other ones are. You'll notice corresponding angles. Corresponding basically means matching. And when we say matching, we're talking about matching positions. When we have drawn this, we have, and I want to erase some of this stuff just so it gets cleaned up a little bit. We have a top set of angles based on a crossing. We have a bottom set of angles based on a crossing. Corresponding angles are in matching positions. Top left matches top left. Top right matches top right. So for instance, top left, that's how we were able to get this pair of corresponding, 1 and 5. Can you tell me another pair of corresponding? Bottom left corresponds with bottom left. 3 and 7 are corresponding. Top right corresponds with top right, 2 and 6. Bottom right corresponds with bottom right. And one of my favorite abbreviations for these is to simply say angle 1 corresponds with angle 5. Next, we have alternate interior angles. You notice that when we had these lines drawn, that there is a space in between. There's a space on the inside. Well, the inside is, of course, the interior. The outside is called the exterior. Alternate interior, then, are on alternate sides of the transversal, on alternate top and bottom, and of course they're both on the inside. Thus, when we are looking at alternate interior, 3 is an alternate interior angle with 6. I want to emphasize, both of them are on the interior. 3 is on the top, 6 is on the bottom. That's one of the ways that we get alternate. 3 is on the left, 6 is on the right. That's also how we get alternate. 3 and 6 are considered alternate interior angles. And so we could write up angle 3 is alternate interior with angle 6. Can you identify another pair of alternate interior angles? Four and 5 are alternate interior. I do want to caution you, once in a while students make this mistake, not very often, but sometimes. 3 is on the left and 4 is on the right. So those are alternate interior. But that's not true. And it's not true because they're not on opposite lines. To be alternate interior, you need to have like a top line and a bottom line, or maybe a left line and a right line. But alternate interior angles are not on the same line. They're on the same transversal, but not the same line. This 3 and 4, we've already got a word for that. When we've got this picture going on, we know that's a linear pair. And a linear pair is not alternate interior. Alternate interior angles will never be adjacent angles. And that's the big thing that we've got here. Okay, further, we also have alternate exterior. And so, of course, they tell us the same thing. Alternate, so opposite sides of the lines, opposite sides of the transversals, but on the outside. So if we grab an outside angle, go to the alternate side, and alternate side of the transversal 2, we would have angle 1 is alternate exterior with angle 8. And of course, we could then recognize another pair. Angle 2 is alternate exterior with angle 7. Last kind that we're going to have, same side interior. Gotta appreciate how clever the names are. They're on the same side of the transversal. So left-hand side with left-hand side. Angle 3 is same side interior with angle 5. Angle 4 is same side interior with angle 6. And so the types of things that we want to see with these, try to identify them when we've got pieces like this. So, tell me one pair of corresponding angles. Corresponding means matching positions. And given that we have 4 different sets of correct answers here, we just need to find one pair, so I'm choosing to do number 4. Number 4 is in the bottom left position, matching bottom left, so angle 4 is corresponding with angle 8. That's one of the 4 different correct answers we could have. Please notice that the order doesn't matter here. We could say angle 8 corresponds to angle 4. It's the same answer, just written a different way. Okay, what about alternate interior? They need to be on the inside. So I'm going to grab an interior angle. Just because if I'm already going to use angle 4, I may as well go with it. Which angle is alternate interior to angle 4? There's angle 6. For alternate exterior, I'm going to grab this angle 8 and just run with it. Because I already used angle 8 earlier, I'm choosing to use it again. And I'm picking the same angle just so that I don't have as much going on. I don't want as many weird colors in my picture. Alternate exterior then is on the outside. We need 2. Remember, alternate refers to top and bottom alternate, but also left and right alternate. It needs to be both. So that's angle 2. If we had chosen angle 1, those would have been same side exterior. And come back with our last one. And I want to use my angle 4 again just so I can reduce the amount that's going on. Angle 4 is same side interior with angle 5. Same side refers to same side of the transversal, but still on different lines. And if you'd like a little bit of extra practice, try it out. We won't go over it here in the video, but now the next problems are the ones where students tend to struggle with the most. And it's because they have a difficult time recognizing the transversal. a helpful hint is to remember that the line that cuts across, that is your transversal. Transverse means to cut across, so look for the line that's cutting across the other two, the one that connects the vertices. So for the angle pair 1 and 3, which line is the transversal? Is it line L, line M, or line N? After you identify the transversal, what kind of angles are they? Are they corresponding, same side interior, same side exterior, alternate interior, what? Well, when we see angle 1 and angle 3, you notice that their vertices are right here. When we connect the vertices, that's the transversal. So the transversal is line L, and now we need to figure out what kind of angles these are. When we look at these, we can see this is in the bottom left position and bottom left. Bottom left matching bottom left tells us those are corresponding. Now looking at this example B, what is the transversal for angles 2 and 6? Well, we can see the vertex for angle 2, the vertex for angle 6, and when we connect those two vertices with the line, that is our transversal. With a transversal, that's line N, we now need to recognize what kind of angles are 2 and 6. And so we can see this one is bottom right on the inside. This one's top left on what would be the inside. We should recognize those as alternate interior angles. And a piece that sometimes helps students when we've got things this messed up or this hard to see, sometimes students find it easier to simply say, well, if we took this line M and we rotated it, we twisted it so that we kind of flattened it out, so it's more like this. This angle 6 will get rotated, and it's still matching up there. And sometimes then students look at it and say, okay, it's easier to see alternate interior that way. Sometimes having a mental rotation helps students, sometimes it doesn't. I'd just like to give you a possible tool that some students like, some of them don't. It's just a matter of how your brain clicks. And lastly, angle 4 and angle 6. Okay, angle 4, angle 6. When we connect those, we can identify the transversal. So the transversal is line M. And then when we look at these pieces, with this being the transversal, we could look at this several different ways. Well, from here to here, this is of course inside of the angles, so we'd have to recognize this red region as the interior, which of course would force this section, or these sections, to be the exterior. Well, seeing that both 4 and 6 are in the exterior, and seeing that this one's on the right-hand side, this one's on the left-hand side, those two pieces should tell us that they are alternate exterior. And you'll notice I recognize those ones not by using the slanted line part, but sometimes students will use their pencil to lightly shade in the interior. Some students like to do that just so that they can have a better image of where the inside is and where the outside is. just another tool to see if it clicks with how your brain works. That's really all that we needed. 3 different types of problems emphasizing the vocabulary of lines and angles. Once again, I want to emphasize this vocabulary will serve as the foundation for 2/3 of our unit. We absolutely must be able to recognize where alternate interior are. We absolutely must be able to recognize corresponding angles when we have them and when we see them.